Hello and welcome again. In video part 2, we implemented from scratch the building blocks of our model. In this video, we're going now to step a little bit back and go back to the implementation with FastAI, and we'll show how doing this model using FastAI is much easier and concise. And we'll also show that actually using FastAI library, you have access to a few things that we purposely ignored during the implementation from scratch. So let's do it. We started by importing all the library that we needed. And as I said, this program has a tabular data set, and so we built it with tabular models. And we have to import FastAI tabular library to do that. After that, we downloaded the data set. Okay, so, and then we did something to load the data. FastAI provide these functions, which make it very convenient to import data. In this case, we're using a tabular data loaders because we have a tabular data set. So what the tabular data loaders need, you just need to tell where is the data. In this case, we're telling it from DF, we're getting this data from a data frame, okay? And what data frame? A data frame called data set. And you still tell it the path of this data set, okay? And then there is something called procs, okay? So the procs, these are a list of functions, called transformers that you want to apply on the data. So remember when we were building the FastAI model, if you remember, we didn't delete the missing data. The reason is because we have this fill missing, which is just a function that will do that for us. We'll replace the missing data with the mean, okay? And then also remember that we normalize the data. But for FastAI, we didn't do anything because FastAI will have normalize, which will identify all the continuous values and normalize them. And also remember how we've got in our data set. We've got in the origins column, we've got USA, Spain, USA, Europe, and Japan. Okay. But we didn't do anything other than that. We didn't do any one-hot encoding. The reason is because Categorify will do that for us. So what Categorify does, it doesn't create one-hot encoding. So what it does, it will create for us an embedding of each category. And beside that, after creating the embedding, it's a better way of using. It's another way of doing one-hot encoding, but in an efficient way. We'll see that later. But at this point, it just you can just take it. It's an embedding. There are a lot of resources talking about it, but we'll get time to talk it into other videos. Okay. So now, after we've passed it our procs, which is this list of transformers, we want to tell this tabular loader which columns of data that are categorical and which ones are continuous values. So we do that by just providing a list of column names. Okay, with cat name meaning category names and conti name meaning continuous names. Okay, and then we tell it which label are we trying to predict. In this case, it's the MPG. Now we've got something new that we didn't do from scratch. In the Scratch version, we didn't do this on the purpose because we knew we'll still have it here. So valid PCT 0 equals 0.2. What does it mean? So remember, when we're training, we don't want to train our model on all the data that we have, because what will happen? The model will do very good at recognizing those data, but when we give it data that it hasn't seen before, it may not perform well. The reason is when we built it, we didn't have a mechanism to identify whether it's doing well on unseen data. Okay, so to avoid that, we'll have to separate a small portion of data that we can use to validate if the model is very good at unseen data. So that's what we call validation data set. In this case, we're saying 0.2, okay, which means 20%. Take 20% of the data, save it aside, don't use into the training, and only use it to validate the model. Okay, and then we have seed, and okay, we have this seed. So what the seed does, it will, because we training, we want to make sure every time we split a validation set, we always get the same validation set. So the seed will just allow us to randomize the same data set, okay, instead of having a new data set every time we split. The reason we do that is because if I make a change on the model, I want to make sure the improvement that I get, it's coming from the change that I made rather than from the combination of the data. Okay. Next thing we have into our tabular loader is we have the batch size. Okay, so here we don't have to create our data loader thing. This data loader will do it for us, and we just need to tell I want to see 64 data at a time. It will create a batch size of 64. Now the next thing we just load our tabular learner. So the tabular learner is our model, and then it requires us to tell it what the data set is, and this data set is the DLS, the data set that we've just created, the tabular data loader. Okay, and next thing we tell it what kind of architecture we want. Okay, so we want this architecture, layers of 64, 32, and 1 output. So this, imagine, will be, if we, let me go back at it slightly on this from scratch implementation. So if you remember, on from scratch implementation, we had this architecture where we have the layer of inputs which get modified with the weights and add them together into an output layer. That's the architecture of a linear regression that we have from scratch. But now we want even something very improved. Okay, so we'll have a different architecture. This time we want a deep learning architecture where we have a bunch of layers stuck together, and this is how you do this in FastAI. You will just tell it, give me a layer of 64 units, give me another layer of 32 units, and the last layer will be 1, which is equal to the how many output do you produce. Okay, and Data will do that for you. Okay, all right, so we've got also the loss function. So this is how you tell FastAI the loss function. will just say, yeah, use the mean square error loss, and that's found into the PyTorch functions, loss functions. And we also tell the metrics, I want the root mean square error to be my metric. That's simple. You don't write anything, it's already there. But it gives you also, you can also define pretty much any function and pass it in there. It will still work for you. Okay. Now, I want to talk a little bit about overfitting. So we here in Scicode is our architecture of this neural network. But as you see, we have 3 layers here. Now, we could provide as many layers as we wish, but the problem is this one. You have to tread carefully, because if you're providing a lot of layers, although sometimes it may generate a good improvement, it may also make sure it may also make your model overfitting. So overfitting happens when you have a model which get very good at memorizing your data set, okay, your training set. It memorizes everything, every details of the data set, so that when you provide it a training data set, it will give you almost a perfect model. But when you bring unseen data, bam, it doesn't know anything because it just capitalized on the training data. Okay, so we want to make an architecture carefully so that you don't fall into the trap of overfitting. All right, so there are a lot of things we'll learn on how to avoid overfitting, but this is one of the dimensions where I could say this is a red flag, just be careful. All right, so overfitting happens when, in the scenario like this one that we see here, the green line that you see there is, I would say that's decision boundary that overfit. Okay, it's trying to separate all labels, even going inside the zone that's majority blue, trying to get just one red. That's an overfitting. And we can see this on the right side with this regression, where the line of fitting should have been just a straight line, but we ended up having something polynomial, which goes from, it creates a polynomial function which is just touching everywhere into every dot. That's also another overfitting. Okay, so how you know if your model is overfitting? The model is overfitting if it started training properly, the validation set and the training set all going down as expected, and then suddenly the loss of the validation set start going up, whereas the loss of the training keep going down. So yeah, I mean, let me show you into the code. We've done that when we were building this model, FastAI model. Remember when I showed you this graph, plot loss? So this graph showed, it shows that the blue is the trend. The training kept going, the training loss kept going down, and the validation loss kept going down, but at some point it just plateaued. So that's a good one. Okay, it didn't get worse, it just remained, the validation had remained, it remained the same. Okay, but now imagine the scenarios where for sometimes this red, which shows the validation, is going down and then suddenly it's going up. That's called overfitting. Okay, yeah. All right, so I've already talked about the loss. Now the next thing what we do, we fit the model. Okay, so all these things that we have here, the tabular learner, what we created is just in architecture. We've just taught we just built a model. It's just like we had this function. So remember, in the Scratch, we created all the functions, but yet we needed to call them by doing some loops and then get them working. That's the same thing. Everything we have here in this one line is the architecture of this model. We specify what data goes in, how many layers, what the output is, what function, loss function do we need, what kind of metrics, and that's it. But it's not doing anything. Now, to get it running, we have to call fit, okay, the function fit. So FastAI provides this function fit one cycle, which we'll see later. It does the fit, but in a better way. So I always call fit one cycle instead of fit. So we call fit one cycle and tell it do a pass of 20 times into every single data, okay, every single example, and make sure you're using a learning rate of 0.03. So basically pretty much what we did. So now notice how you just done this in one line, rather than building the whole loop of things and upgrade it, like the whole thing that we did from scratch. But here it's just one line, and tada, it's done. And there you go. We are done. You've got your model working perfect. All right. So now, is that all? Well, maybe I may say a little bit about, let's talk a little bit about validation, because validation set it's a very interesting thing to consider. Among everything that we've done, without a good validation set, your model will definitely fail. Okay, so when doing the validation set, it happens most of the time that you've spared the validation, you've trained, and then when you evaluated, you didn't like the metric, we didn't like the loss that you saw on the validation, so you want to improve it. You change something and you run it, and you don't like it, and you keep doing that 1,000 of time, in the end you have something that's doing well on the validation set. But the problem is, by keeping tweaking and tweaking on the validation set, you ended up overfitting your validation set without realizing. In other words, you ended up cheating your model. Okay, so that usually happens. So normally when you have enough data, to avoid that happening, you need to create another, you need to separate or split another on the side, another data set that you don't touch, you don't even associate with the model at all. And that's called a test set. That test set will be separate. It will be just kept somewhere, no one touching it. Once you're happy, you have the model working properly, then fit it to the test set and see if it's still doing well. Okay? Usually, like in companies, let's say if many companies, what they do, a manager of the company or of the department requiring the model, they'll get an expert to build the model. But the manager will hold a test data set somewhere, no one knows it. He will tell the builder of the model, build me the best model that you can for this problem. Once the builders come and say, we've built your model and everything's fine, the manager will say, okay, let me see. He or she will take that data set, fit to the model and see if the model actually doing well. So that's the importance of having a test set. Okay. All right. So the other thing is splitting. When we were splitting the validation set, we just split it by randomly taking 20%. But that's not always the case. Depending on the nature of the problem, depending on the data set you have, you want to make sure that the splitting makes sense. Okay. For instance, if you have data like this one, sequential data, this data, they have a frequency. Okay. They start from where and then go back down and go up. So you can see that this is happening on a periodic time. So what you want to do, you don't want to lose this frequency trend, or you don't want to cheat the frequency. So what you will do, you split this validation, the validation set, by just deciding at some point in time, you say, from now on, from here to there, this is the validation set. Everything that started from here will be for training set. And then you also decide what data points you want to start from and take it as a test set. So an example, let's say you want to predict, and this is something probably we'll do in another video, but let's say you have details about sales, like some people have been coming and buying stuff, and you want to predict let's say you want to predict, maybe I would say I'm trying to all right, so let's say you want to predict a shopping list. Okay, so what you'll do, you don't want to randomly split the data set. You want to just see how did this person buy things up to a particular date, trend from that one, and then assume that the way the behavior that you observed will be also the same behavior in the next 1 month, for example. So you want to validate on the next 1 month, because when you predict, you'll be predicting data in the future. So you're training by time, you're not training just randomly. Okay. So another important thing we've covered is that you're going to always to deal with something like this. You start by collecting data. In this case, we got the data from websites. And now when you got this data, you don't trust the data and just fit them. You want to do some cleaning. Like we've done some minor cleaning in this video, but most of the time you may have to do a lot. I would say many machine learning engineers will tell you that they spend almost 80% of time cleaning data rather than cleaning and getting ready the data rather than building the model. So after you have clean data, provide them to the model, and then the model, you train it. Once you've built the model and happy, evaluate it on unseen data. In this case, that's the test set. If you're still happy, then deploy this model to production. And this will help you to capture new data, because once it's go production, people start using it, collect the new data information coming, and then use them to train your model again, and so on, and the cycle continue. All right, that's it for this video. To summarize, we've built our first deep learning model, and we've talked a little bit about validation set and how to avoid overfitting, and we've also touched a little bit about the general machine learning workflow. In the upcoming videos, we'll see even more interesting problems that we can solve with machine learning, and we will eventually develop those models. And so I hope you enjoyed, and you're going to have fun playing with these notebooks that I used in my presentation, and I'll share the link in the description. And if you haven't subscribed, you can click the subscribe button so that you will be notified when new videos get uploaded. So I'll see you next time. Bye.